Hello everyone, my name is Jason Gillham. I'm the Chief Technology Officer here at Impossible Metals. I'm going to give you a little tour of Eureka II, our proof of concept underwater collection system that selectively picks up nodules. So our system works by, as I mentioned, selectively picking up nodules. And so we have our vision system on the front. That consists of a number of deep sea power and light lights that spit out just under 10,000 lumens. And then in between the lights, you can see our cameras. These are our designs. We've a couple older versions, and then we're testing out a newer version right now that we're progressing to. Those vision systems, they see the nodules and track those nodules that as they progress back to these arms. And so these are Delta-style arms with, again, our own design. They're a Delta style, so they move very quickly, more like industrial pick and place, where we use some 2G engineering actuators and then our own algorithms and code to control that. And then they put the nodules into that scoop that you see at the bottom, and that pulls the nodules up through a tube and into the vehicle, into this hopper, where we're able to then pull those nodules out once we've collected them. As we're adding the weight to the vehicle, these buoyancy engines, and so you can see these glass spheres, they're full of water, and we using these hydrospace motors and some pumps, as well as these valve packs, we move water in and out of those tanks to adjust our buoyancy. And then we always keep a slightly positive buoyancy, and then these vertical thrusters from Copenhagen Subsea, that's what keeps us down and controls our altitude, as well as the horizontal thrusters to control our direction. All of that's controlled by these driver tubes that are here underneath the hopper. You can see a couple there and a couple on that side. And so these are our titanium vessels of our own design that control the thrust of the vehicle, as well as the buoyancy engine work. You noticed in the middle here, also under the hopper, that's the battery compartment from a Nukton. That's a 14 kilowatt hour battery pack that gives us lots of capability. And then the whole system is controlled by this control housing or compute housing here, which contains a number of both off-the-shelf as well as custom circuitry to make it all work. It's all connected using predominantly McCartney subcon connectors. And then at the front, we have a series of sensors from this Imagenics scanning sonar that we use for obstacle detection and avoidance, through to the FINS INS and Nortec DVL to track position, aided by the imaging system, as well as up on our foam pack, a Sonardyne USBL to track everything. And then up on the top of the vehicle, but currently just sitting here in its bracket prior to getting mounted on the top of the vehicle, is our antenna that includes some ZEOS satellite antennas, as well as the wireless modem from Trident. And then everything that we do, we monitor with some monitoring cameras. So you can see a couple sort of selfie cameras that are there looking back at the arms as they operate, and so that's the deep water exploration selfie cams that we use to watch how the whole vehicle performs while we do all of our testing.